Okay, how do we identify diastereomers? So, did you remember that on your discussion manual, it asked you to do, which means if they're wedged up, they're pointing out. And then this one is dash. CO2H is the brown one. CO2H is dash. These two are wedged up. These two, so I make exactly the same configuration, O hydroxyl group wedged on both sides. If I do this on the carbon, what did you see? I know this is this one. Then put this way. So you have the carbon in the middle, and your COOH is in the plane. Your hydroxyl group is dashed into the board, and your hydrogen is out. This one, your methyl group is in the plane, and you have a hydrogen dashed into the board, and your your hydroxyl group wedged out. Then you assign RNS on this one. So you need to do that rotation in your head. Okay, this one. How do we identify strengths of a nucleophile? How does a nucleophile behave a protein vs protein? Oh, this is a good question. Okay, so how do we identify the strengths of a nucleophile is exactly on your worksheet 6. Note 6, my bad. So on your note 6, on the page of nucleophile and base, there's, so this one, strength of a nucleophile. Where's my yellow? Only depends on whether it's polar or not, and whether it has charging or not. So that's why I asked you guys to compare in my note 6. Whether it's polar or not, did you still remember the electron I draw on the sulfide? So that's the two basically back to here. And the reason for why sulfide is a good nucleophile is on the side. It's not that useful because I think at your stage, you're like learning so much, it's kind of really hard for you to compare. So I put the table. If you see it's a strong nucleophile, use it. If you didn't see it and you see them in strong base, which means it can be a good nucleophile and a base, but the strong base is the one that you want to use. So it's make your life easier in this way. Later on, by practicing more, you can generously have a sense. So for me, it's kind of, I know it's electronegative, and then just, I know it's a good nucleophile for, like, I know it for a long time. That's a kind of a sense. Good. How does a nucleophile behave in a protein and a protein solvent? Because I know he used a Fufi toy, so I go to the video and see that toy, because he said he's going to bring that one, but I didn't see it. I think it's in the toy part. That's in the toy part he talk about the strengths. Like in protein it's going to be one way, in a protein is the other way. That thing is only used for in multiple choice, like which one is going to be the quickest one. So I don't remember that way because in my mind, SN2 is a reaction that is very negative. It's like electrons donating out. It's nucleophile or base. So any polar protein solvent which has hydrogen flowing around is going to hurt my nucleophile. So that's kind of I understand it in that way. In polar aprotic solvent, which I don't have that hydrogen flowing around, my nucleophile just go to attack my center or grab the hydrogen. Otherwise, if I have this, either base or nucleophile is going to grab this one directly instead of the partial positive carbon. So it kind of hurts my reaction. Did I answer this too? Good. Okay. This one is a hydrogen. This one is a dash hydrogen. So which hydrogen I'm going to grab? This is a good leaving group, right, and this is the secondary carbon. So I have identified this is going to be E2 reaction. reaction according to our table. So after you have done all this, which one is the anti-hydrogen? This one is syn. So this one
the
is
dashed hydrogen.
yeah. So this one is syn. This one is anti. So this one has to be the one that's the base, which is this. So because it's backward, I just erase this one. So this one equals to O minus. So this is base. So equals to base minus. And this one is gonna to, I'll use another color. Hopefully green you can see. Okay, this is gonna grab the hydrogen,
Right.
form the double bond, kick the leaving group off. And since this one is sp2, you lose this wedge. Because it's sp2, sp2 doesn't have that wedge. Oh, so the secondary carbon, because this center carbon is bonded to 1 and 2.
Okay.
If it has 2 carbon neighbors, it's secondary. I'm going to make the chain now.
Yeah, there we go.
Yeah, methyl.
Okay, methyl, yeah.
It's a methyl group. You lost that anti-position hydrogen. This one is going to be no reaction.
Okay.
Okay. Now, this is a syn hydrogen. Now, if I erase this, what would happen? First, I erase this, means this one is a hydrogen. I didn't draw. This one is a methyl, and it has a wedge hydrogen and a solid hydrogen that I didn't draw. So where are my anti-position hydrogen? It doesn't have looks from this because I'm looking for a dash hydrogen, right?
There's no dashed hydrogen.
But I can do free rotate because I'm not in a ring. I'll use the yellow one. So I can do the rotation.
Right.
If I do the rotation, I'm going to rewrite on my carbon 3, I have a OTS, just good leaving group. It's not necessary to be TS, I just don't want to write. And that's it. So if I rewrite everything into this, I want to use a small base. There are plenty of hydrogen. So that's become the question, which side do I go?
Right.
If it's a small base and or it's a bulky base. On each side, let's draw the products. So if it's on this side, it's going to be this. If it's on that side, it's going to be that. So these two have no difference to me. There's no difference to me.
Why is there no difference?
Because, yeah, so two substituted alkenes, so these two both should exist. But you're not going to be tested on this. I just made this question. So
okay.
it's kind of usually it's the if you have been asked a question on either it's Zaitsev or Hoffman, one of the substituent is like going to be more substituted alkene that you need to make the choice. But
What would a tertiary substituted alkene look like?
so just put more thing on. You can have
Oh,
you can
okay.
have as much as you want.
Okay.
Yeah. So these two should both exist.
But we
Because-
wouldn't-
Those would be
Two
Products,
products.
okay.
Yeah, but no, this question is not
okay.
a good exam question because it's going to confuse student.
Mm.
I just made this question from the ring out of here to let you guys know.
about the anti-difference.
Yeah.
So when we're given it, like let's say there's a problem and there's an E2 reaction and it's a like a straight chain alkane or a branched alkane.
Uh-huh.
So like hypothetically on the test, there's only one place to put the double bond, right?
Yes. Yeah. That's what I'm saying.
Okay. We shouldn't have to worry about like
No.
oh, okay.
No.
I'm
But
just not
you,
gonna give it that type
you
problem.
do need to differentiate the syn or anti-hydrogen. That's the only point we want to test you so far.
Okay, that's what I was getting confused about. Okay, that helps a lot.
Okay, question on this question. I know I made this question into 3. One is the one that's original on a, and then it's a no reaction, and then it's this one, which actually have 2. But this is the kind of good exercise that you can do on your own. Think about if I have a actual methyl group here, what's my products gonna be?
Okay.
Yeah. This is actually one of the Zaitsev and the Hoffman because it's a bulky
the
base.
first one,
So think about this one because now we don't have the problem of which anti-hydrogen I have. They both have. So the product is going to be look like this and this.
Wouldn't it be the first one?
So which one?
The first one.
Why?
Because it's too bulky to attack that position.
Yeah. So this one is less substituted because it only have one. This one have like two substituted. So if I change the solvents in the condition into CH3OH, CH3ONA, it's going to give you this. But this is a bulky base, so it's going to give you this.
Wait, you flipped it. Tina,
Yeah.
shouldn't the butanol be on the bottom and then the
Doesn't matter.
oh it doesn't matter.
Wait, I'm a little confused. How did you get rid of the other options for the double bond?
You didn't get rid of it. It's just the minor.
Yeah, this is the major. The
How
other one
that's
is
the major.
because this one is the more substitute. It's the thing in a square.
It's the thing in the square.
In my note
Oh, okay.
6 in a square. So in a square, I put them like both have this two. One is Hoffman, the other is Zaitsev.
Wait, I thought we were getting tested on that though.
No, but you still need to learn that anyway.
Oh, okay.
Yeah.
Okay.
So it's just a matter of time.
Okay, that's true.
So I put major on one, major on the other.
Okay.
So which means both is going to form, but just one of them is going to be major. Make sense? Okay. So LDA looks like this. So this is one of the bulky base. The other is LDA. Looks like this. Those are the only two bulky base that you are going to learn. Yeah, question?
And then, so obviously, I don't know what's the OCH3, the one on the top.
Yeah.
That's the nucleophile, right?
That's the base. This
Oh,
one is
and
the
then
base.
Sorry.
So
the bulky base.
it's CH3CONA.
So you know the solvent at the bottom. How come that can't react?
It doesn't matter for elimination.
Oh,
We're going to follow that rule again. But this time you don't have the table. Because I don't have the table. You need to think on your own. Okay? Challenge yourself. No, I know you have your table aside. So good living group, 1, 2, 3 tertiary carbon, weak nucleophile, SN1.
Tina,
Yeah.
the question says what is the SNL product?
No, you should not
Wait.
rely on that.
Wait, can we move to example 3?
Oh yeah,
That's
sure.
like the harder one. That's the one I think everyone wants to see.
Oh really? Oh, which one?
No?
No, you shouldn't ignore what the topic told you. You should identify yourself.
Example 3 doesn't give you the answer.
Yeah, I like example 3 because you have to figure out which one.
Oh, okay. So you just.
Because it's easy to draw the products and it's hard to like figure out the reaction.
Okay.
I haven't been able to
Um,
study those midterm
This one, okay. So this one is a small, strong base.
So because it's a small, because it's a good nucleophile, it has to be SN2, right? Because
Yeah. Yeah, just use the table.
okay, all right.
Yeah. So far. Yeah. It's a good living group. Secondary. What's the solvent?
Protic.
Polar protic. But it doesn't matter actually. Just want you to recognize for that. This one is E2. Look at the table. So this one is going to be. Oh, identify which hydrogen to go. This one or this one? A or B? A or B? A, because of we just go over that, right? It's the wedge hydrogen that you are going to take. So this is this. Everything keep the same. Okay. This one, secondary, good living group. What's this? What's this? Yeah, it's SN1, but this one is an acid.
Is it carboxylic acid?
If this one is CH3, it's
Oh,
yeah,
okay.
it's carboxylic acid. If this one is a CH3, it's the
Acetic.
acetic acid. But this one is not. I think it's a formic acid.
Oh, okay.
Yeah, but just the acid because think about this. OH with this carbonyl next to it, it's always a acid. Just remember this.
Okay.
OH with a carbonyl next to it. You're going to learn this in the first chapter of 180C. You're still 3 months away from that.
So it'll be SN1 then?
Yeah.
Okay.
And you always remember SN1 has the E1 as minor product. This one, I want you to be ready for the midterm. So write all the product and identify which one is major. Identify which one is major.
So the E1, like you're saying, is side reaction.
Side
so we
reaction, so
Probably
you-
won't produce any major products, but we should still know that that's a thing.
And you should write the thing on. If they ask you, write all the products and identify which one is major. In this case, all the SN1 products should be major, all the E1 should be minor, but you should write everything on it.
Okay.
So, first, major. SN1, the product looks like this. So it's going to be racemic, so it's going to have 2. And this. Oh, I'm so hungry.
Wait, Tina, if we do plus minus, we won't lose points, right?
You won't, but I just want to show everything.
Okay,
Yeah.
just making sure.
Yeah.
Wait, how would you show plus and minus, like, as a way to save time? Just, oh, okay.
But
So
you
But do you have to still draw the stereochemistry then?
yes.
Okay.
And then this one, the middle one, it's going to do the E1. So I just told you this. It's going to be like this. One of them is CH3 hydrogen. And this one is hydrogen as well. And then also so there are 4, and these 2 are major, these 2 are minor.
At the beginning of the thing it says what is the major substitution or elimination products? And as part of the question.
Yes.
But you're saying that just for clarity on the midterm, we should write all
No,
the
she's just doing all of them.
products. Oh, just for
Yeah,
us to know.
my question here is all major.
How did you get the minor E1s?
Minor E1s,
Yeah.
you do elimination on both, on this side. Because you have a carbocation and then it's a hydrogen here.
Why wouldn't you do it on the other side?
Oh, translucence.
No, yeah. Just, yeah, for your case, just remember this is good. Because, you still want to form, maybe the other one can also put on, but I think you just need to grab the hydrogen, that's fine.
So, okay.
This one's E2, small, strong base. Yeah, bye, see you. And this one is the fast time coming. I'll finish this one now, yeah. Actually, this one, if you want to do on both sides, these 2 are the same. That's the reason. This one is no reaction. Good?
Why is that one no? Because it's bad leaving group?
Because you cannot, how? It's like you nucleify your bases with yourself.
Thank you.
Yeah, see you on Monday.
Wait.
I think you're coming to my office
I
already.
have a feeling I am too. I know.
See you on Monday.
I'm so
Wouldn't that-
sorry.
Tina, wouldn't that make an epoxide?
What?
Wouldn't that make an epoxide?
Epoxide, you need another carbon.
Yeah, but what if
No, you cannot. This one, if it's this, I know what you mean. If it's, oh that's equal sign. But this one you cannot attack here.
Okay.
Good? Okay. That's it. Any more on this? Yeah, question?
Oh wait, so you can't attack the other carbon because leaving group is not anti, is that why?
It's not because anti, it's because this one is the base that usually flowing around. Now you have the base and the substrate together. It's you cannot do that because what you want this. You want this one to
Yeah.
attack here.
Yeah.
Then how can the bond form like a,
I see what you're saying.
Yeah.
Okay. Yeah, that makes sense.
this one you could. Go ahead to practice. There's a 11, there's a 12. It's the same thing. Go ahead to practice on 12. Yeah.
Can we do C on the other side?
Yeah,
Example
sure.
1.
Last one. No. See? This one?
Yeah.
Okay. See? This one's tricky. What's this? Is that a good living group?
No.
No reaction.
Because it's a bad leading group?
Yes, and you cannot do the acid base.
Oh, I see.
Yeah.
Can you send the link out again with the worksheets because I wasn't in the first email.
Okay, yes. I'll send out in this week.
Okay, thank you.
Any more question on worksheet 11? No? Okay. I think I can. Yay!